This is a podcast from the Nuffield Department of Medicine. Professor Sir Andrew McMichael tells us about recent developments in the search for a vaccine against HIV. Hello, Andrew.
Hello, Anna.
Do we understand HIV any better than 5 or 10 years ago?
We certainly do. So we know a lot more about the virus. We know a lot more about it, how it avoids immune responses, how it establishes itself in the body. We know a lot about the envelope, which is the target for antibodies and vaccines. And we know much more about how to treat it effectively.
What are the major lines of research today?
Well, there's a huge effort going into vaccine development. And despite the treatment, there are still 2 million people being infected every year. And more people being infected every year than actually start treatment currently. So although the treatment's been rolled out into Africa and Asia, it's not reaching enough people, and it probably never will. So there's a real need for a vaccine. For most vaccines, there's some evidence that people who are infected, for most viruses, so people who are infected are protected from reinfections. So if you've had measles, you don't get it again. If you had chickenpox, you don't get it again. With HIV, we don't really have that evidence. So we don't have examples of people who've cleared HIV and then are totally resistant forevermore. However, we do know that a lot of people control the virus infection much better than other people. And some people have survived 20 or 30 years without needing any treatment and are controlling the virus really pretty well, although they haven't cleared it completely. Other people might progress to infection in about a year or even less and progress very rapidly. The keys to that really are coming in the very first stages of infection. So the very first immune response people make can really determine the whole outcome, whether they progress rapidly because that response is totally inadequate, or whether it's so good that they actually control the virus really well. So one of our aims with a vaccine is to try to mimic the latter. That's not as good as completely preventing infection, which is what an antibody might do, but because that is so difficult, and some might say it's almost impossible to get an antibody to neutralize all the variety of viruses, of HIV viruses that there are out there, and that this is an alternative way to go to try and make sure that the immune responses people make are better and they are less likely to develop disease.
How far are we from a vaccine that would prevent HIV infection?
We're a little bit closer than we used to be. We're still a long way off, I think, but there was a recent trial 2 years ago in Thailand, took about 5 years to do, which showed that there was about a 30% reduction in infection in people who are vaccinated. Now, a flu vaccine, for example, we would hope for 100% protection. So 30% is not terribly good, but it's a lot better than zero. And if that result can be repeated, and that is a big if, but if it is repeated, then I think we've opened the door slightly. I think that it will be possible to improve on that 30% and get it to 50, 60, 70%, and then we really would have a vaccine. But that whole process would probably take at least 5 years to get to that more efficient vaccine, and then another 5 years to roll out to give to large numbers of, I'm talking millions of people.
Why does your line of research matter? Why should we put money into it?
Well, my line of research is to try and develop the vaccine. I'm not the only person doing that. I'm part of many groups around the world who are trying to design vaccines, and there are two kinds of approaches. One is to find something that will stimulate really good antibodies that will neutralize the virus, and the other is to either back that up or have a sort of an alternative strategy, which is to harness the cellular immune response or the T-cell immune response, which controls virus-infected cells and controls infections in the body. So it might not prevent infection, but it could prevent disease. And that's really where our work's going. And obviously it's important because the infection is so important.
How does your research fit into translational medicine within the department?
Our research, or my research, has been looking at immune responses in humans for longer than I care to remember, I think about 30 years. We started working on flu and looking at ways in which we could use that immune response possibly to develop flu vaccines. And actually Adrian Hill and Sarah Gilbert are now in the department are doing that. But my main attention switched to HIV when that became a real problem in the mid-1980s. And we've looked at the nature of the immune response to HIV, how it works, what controls the virus, and from that, that's led us to developing our vaccine strategy. And we now have a new type of vaccine approach that Thomas Hankey and I in the department are trying to develop, and also working with Lucy Dorrell to test that in the very early trials in volunteers in Oxford. And if that looks promising and gets the kind of immune response we want, then we'll join up with other teams around the world to sort of roll that out into bigger and bigger trials. And if everything goes really smoothly, then we could try it to see whether it really prevents infection or controls infection, probably in about 10 years' time.
Thank you, Andrew.
Thank you.